All right, welcome to day 2 of Solve by Elimination. Quick recap. We take the two equations, we're going to combine them, and a variable should disappear. So we're looking for same number but different signs with the same variable. If they were the same number and same signs, whether positive, positive, or negative, negative, we just got to change the signs of one of the entire equations, and we're good. So here's our recap. Combine them together, and y disappears. This is the elimination of elimination. We have one variable left, and we can solve for it, and then we plug back in. And this is the same stuff we did with substitution. If I'm going too fast, just hit pause and write stuff down. It's fine. Again, here's us just changing signs. Like, oh, well, they both said positive 2. So if I just change the signs everywhere, then they make 0. Y is the only one left. Get an answer, plug back in. Get another answer, get our final answer. So look at the day 1 video if you need some more help with that. But I want to talk about what happens here. Looking at our original equations, if I combine them right now, nothing disappears because that makes 15 or negative 15, and this makes a negative 3. Well, if they don't disappear, I really shouldn't be combining them. But if you remember, kind of like us changing the signs of everything, we can literally do whatever we want to any of these equations. So what we did, because again, we're looking for like a 3x and negative 3x, or 7y negative 7y. So even though I don't have that, I could take this top equation, multiply by 2, and then this would say 6y, and this would say negative 6y, and that's what I'm looking for to combine. So that's what I did. Took this 2, and just like the negative 1 that changed signs all the way across, this basically distributed to everything. So 2 times negative 10 is negative 20. 2 times 3 is 6, and 2 times 1 is 2. So and that's what I did over here. Everything gets distributed, everything on both sides, and so really instead of like writing a 2 above everything or having all this mess, really if you just want to put like a giant parentheses and a 2 on the outside, we're not technically supposed to distribute over an equal sign, but if this helps you remember to get everything with that 2, let's go for it. Because I would rather that than like, oh, well that part of the 2 is gone and then all of a sudden your answer is wrong. But once we do that, this equation is kind of useless to us. We might be able to use it, but we're now looking at these two. We've recreated this one. So I don't need that top one anymore. I need this bottom one. Once we combine, y disappears. Negative 25x equals 25. And again, this is kind of our checkpoint where we take the two equations with two variables and combine them together, get one variable, plug it back in, get the other variable, boom, it's done. So we can manipulate one of the equations by just multiplying. You could technically divide, but you might get some nasty fractions, and it's just easier to multiply everything. You might get some bigger numbers, but at least they're not fractions. Nobody likes fractions. Sorry, person who invented fractions, but let's be honest. So change one of them and then combine. So the trick is trying to figure out, and this is where you really have a choice. I could have chose to eliminate x here. I could have chose to eliminate y. On some of these, I could have eliminated y, but I noticed it was a lot easier to eliminate x. Try to find the one that's going to be easiest to eliminate and go with that one. If you do it the other way, it's not wrong. It just may be more work. On this one, again, I had 3x and negative 6x. So I figured if I can just make that into a positive 6, then when I combine them, they'll disappear. Well, how do I make 3x into positive 6x? I'm not going to add. I really don't want to divide. Multiply by 2. And that gets me, that gets me 6x here. And that 2 just goes to everything. Becomes 4y and negative 4. Combine. Here's my elimination. Get a variable, plug back in, get the other variable. Okay. So now, spoiler alert, I have all these. I'm looking here, and I can't really get 2 to match 3, but I can get 2 to match 10 by multiplying by 5. So I do that, and I get 10x, 10y, and 80. Problem is, 10 and 10 do not make 0. They make 20. And we have to get these to eliminate. They have to eliminate. So we can just change the signs like we did in previous video and be good to go. Or we can just change this sign. Maybe I should use the thinner one. Let's trade these. I know that seems petty, but there we go. Or we could change this sign because -5 times 2 is -10. -5 times 2, and we could do it that way. So what we're looking for is I need different signs, whether they are here where I'm eliminating or whether it's here on the outside. Technically, there's an invisible +1 if we want to get technical. One of these, but not both, has to be different signs. So we can change the signs at the end if we want to, because we're looking for different signs. Again, sorry for the messiness. I got 3 to match 9 and 3 to match 9 if I multiply by 3. Well, I need a different sign somewhere. So I needed a -3. Which made it -9 and +9, and again, this guy, once we transform him from here to here, and if you need to go back and rewind and press pause, do it. From here to here, we don't need this guy anymore. 9x minus 9x, 9y or -9y, +9y, both those 0, -10. Variables gone, both variables gone. This is a no solution. Again, here's another one where I had 2 can match 4 by multiplying by 2, and I need it to say +4. So I did a -2 instead. And again, I'm not going to talk a whole lot about these. Hopefully at this point, well, that's the last example for that day. Then we'll go to day 3. But hopefully ask questions in person if you need it. Those last few went by quick, but they all end the same. Once you get that first variable, once you combine them to get like something variable equals something, and it's a quick division one-step equation, they all end the same way. So go back and rewatch it, press pause if you need to.